Another part of your immune system are these proteins known as cytokines. These are small proteins, little hormones that actually then trigger cells to act or to not act, to do things or to not do things and such. And your white blood cells, your antigen presenting cells and such, they will release these antigens, these cytokines and such, and they will travel and then they will trigger other body cells uh, and cause part of your immune response. Sometimes they overwhelm the body and the immune response actually ends up doing more damage. Uh, and so you can have what's known as a cytokine storm, and then that is a dangerous position to be in because you need medical intervention to help counteract all of the things that are happening to your body and all. So, but that's another one, cytokines. Now we did the antibody. No, we haven't. Here's cell-mediated immunity. I get tripped up on these sometimes. So this is where you have the cell. It's within the cell. It's intracellular pathogens, if you will. And your T cells have been shown the antigen mixed with that MHC1 protein and shown. And they will then see that, and you have your T4s and your T8s and all. When they are shown that, along with a cytokine, and sometimes this cytokine, they're known as interleukin 1 or interleukin 2. When these two things together show up, they co-stimulate this, and then they cause that T cell to become activated. So the first thing they do, they grow and then they divide. And as they are dividing, they are becoming specialized to just that specific antigen. And since they are all the same, they'll refer to those new T cells that are produced as clone cells. This differentiation, and it's all geared toward a specific antigen and such, starts off with these T4s. These T4s, they are specific to that antigen. They get activated by this, and then also sometimes by that MHC2, or really by that MHC2 complex as well, when they've been shown it and such. And then they help trigger, through the release of cytokines, other T cells. So if the T4 isn't there, it can't produce the other cytokines that are needed to trigger the other T cells to activate. So these T4s are also known as these TH, these helper T cells, both in the antibody and in the cell media. All of this, they help regulate all of this immunity. You lose your T4s and you lose your immunity. HIV, the virus, actually goes for these types of white blood cells and destroys these. It invades these specific types of cells, destroys them, and so your immune system is gone. So the helper cells, they are activated by the MHC2. The killer T cells, these are the ones that are really, these guys are really, they're really tough cells and such. You don't want them all around all the time because they're pretty bad dudes. But they are activated by the MHC1. And they're also activated with the cytokine, like interleukin 2, IL-2 right there. They activate these T8 cells, these killer T cells and such. And these are the ones that will actually go and kill the cells and all of that. And they do it by, we mentioned earlier, poking holes in the cell membranes, causing that cell to rupture to lyse. They also can release materials inside of a cell that activates enzymes within that cell that actually destroys that cell's DNA or that RNA. And if that's a virally infected cell, that's a good thing. And then they will increase certain phagocytes, increase the phagocytic activity by secreting a type of cytokine, if you will, a gamma interferon. While all this is going on with the T cells, the B cells and such, some of them, the T cells, as they're going through that differentiation, instead of cloning, they just get pushed into the wings, waiting in the wings, if you will. And those are the memory T cells. If the invader shows up again, that's when these cells will become activated and such. And they will come on with a even greater urgency, faster and stronger, so that you won't go through the sickness period and such that you did the first time you experienced that antigen. The B cells, they fight off through what's known as an antibody mediated. The T cells are for cell mediated and the B cells are for antibody mediated. They have to be shown the antigen and such. They're located in places where blood and fluid are going to pass through, in the spleen, the lymph nodes, and the lymph nodules, the tonsils and such. And when shown, they will differentiate into plasma cells. And plasma cells are the cells that actually make the antibodies and such. And the antibodies are specific to the antigen that is found within the blood. So they have to be shown that. It's presented to them with the antigen presenting cells. And it's when the antigen is mixed with the MHC2 complex. And that also, when that happens, it's triggering the T4s at the same time. But the B cells see this and they make these antibodies. The helper Ts help this and such in a little way, but they will stick to a B cell, the helper T will, and they will secrete that cytokine interleukin 2, and that will help the B cell to become and to clone into these plasma cells. Other cytokines and such are produced by the helper T cells and such, and they enhance this proliferation of the B cells. That's why those T cells are referred to as the mediators of immunity. You lose them, you can't mount the antibody defense either. So an active B cell can actually become a clone of the plasma cell. They can clone themselves out, and they can be producing antibodies at a staggering rate, but for a short period of time and such. And these antibodies are specific to the antigen. They're travel through the blood. Anywhere the antigen is found, they're going to come into contact with it as such. Some B cells don't become plasma cells, but they become memory cells, so that if the antigen ever shows up, you can fight that battle again without all of the harmful effects that you do the first time. So what is an antibody? It's a protein, and we call them immunoglobulins. These are proteins found in the plasma and such, and they aid in immunity. It's usually it looks like a Y. Think of it like the letter Y, and then where the top part, you'll have another little lines inside of those. And so you have two heavy chains on the outside and two light chains on the inside. And it's that kind of V section at the top of the Y. That's the part where the antigen is attached to, if you will. We've taken antibodies and put them into different classes. And gamma globulin, immunoglobulin G, that is the most abundant. That's found in blood and lymph everywhere. This is the one that will actually pass from mother to baby and all, and impart mother's immunity onto baby. Immunoglobulin A, localized within a mucous membrane as such. These are also passed in the breast milk from mama to baby. This is how a breastfeeding baby keeps its immunity. When it doesn't really have its own yet, it gets immunity and such from mother. Stress, cortisol increase causes IgA to drop, opens you up to infection. IgM, once you've been exposed to an antigen, this is one of the first antibodies that the body will secrete. D goes and helps with B cells and such. Immunoglobulin E is one that is found on mast cells and basophils. Remember, mast cells are in your skin and they secrete histamine when damaged. Basophil, they are red because they contain the histamine and such. So now they're blue, but the histamine is the blue granules in there and also. They are involved in your allergic reactions. They also help with parasitic worms. So how do they work? They neutralize. These proteins have a shape. You change the shape and it changes everything. You change the shape, viruses can't get in. You change the shape, bacteria can't move. You change the shape, things stick together. And when they stick together and large enough, they can fall out, become soluble. And when that happens, then white blood cells can attack and eat. Antibodies can also activate the complement system. Remember, that's a series of proteins produced by the kidneys and such. Or produced by the liver. Kidneys. Produced by the liver. And then these antibodies enhance the ability, or this opsonization, they enhance the ability of the white blood cells to eat these invaders. There you go, complement system, like kidneys, that's produced by the liver and such. And there's multiple ones and you can see right there. And like blood clotting, there's two pathways that is understood, a classical and an alternative. This is a system that it is a defensive system, but you don't want it active all the time. And so it monitors and makes sure that it's needed. Are you sure I really need this? So there's a pathway. And the classical is you go through these steps all the way to the end step. If, though, there is an antigen, and if it is dire, and if you need to get to it, get this system started quickly, that's the alternative pathway. So once you've activated it, it starts the inflammatory process, inflammation. It aids in opsonization, and then it also helps aid a white blood cell in breaking down a bacteria's wall and membranes. So it aids in cytolysis. Memory, we've mentioned memory a couple times, the T cell memory, the memory T cells and the B cells and such. So it's good for cell mediated and antibody mediated. The first time you're exposed to something, it may take several days to a week for your immune system to really kick in. It maybe take several weeks before it actually gets ramped up to where it can fight off an invader. But with memory, if you're shown that antigen, the whole process kicks up within hours. So it's immunological memory. This is how we've actually been able to utilize vaccinations and help spread immunity to a lot of serious diseases throughout the world. So, yeah. An antibody, when you've been exposed to something, it'll show up in the blood. And if we can measure that, that's known as a titer. And depending upon if it's a first exposure or a second exposure, we can see these and such by looking for these antibodies through this, or we look for certain immunoglobulins that show up and all within the body. Let's come back to that.